Hello everyone and welcome to ProRPA.com. Hope you guys enjoyed making your first program in UiPath in my last demo. If you haven't, I highly recommend that you guys check it out before we move on because we are going in a pretty legible way in terms of all the blog posts, and we are gonna have to have these fundamentals on tips so that once we create more sophisticated robots, then we should have these concepts handy, right? Today, in this week's blog post, we talked about if-else condition, which is another activity, same as decision flow. We also talked about input dialog to get an input from a user, and about loops, but specifically within the flowcharts. These concepts are described theoretically in greater detail in the post itself. And in this demo, we're going to create an even better program from the last one to see how these new activities can come into play. All right, on that note, let's get started. This week, we are going to create a program in UiPath to create factorial of a number, right? The first question is what is a factorial, right? In any business problem that would come to you while you have to create a bot for it, you have to have the process, comprehensible for you, and you need to understand what it's gonna do, what all different steps are gonna be involved in it. Factorial. I don't know. Let's check it out, right? So factorial is defined as the product of all integers less than or equal to the number itself, right? For an example, factorial of a number 5 is going to be 5 multiplied by 4 multiplied by 3 and multiplied by 2, which gives a total of 120. So what the program is going to do is it's going to ask for a number, right, from the user itself, and it's, let's say, 5. The user gave the number 5, and the output that should be displayed should be 120, which is the factorial of 5, right? That's what is needed. And I've also talked about algorithm, which means the sequence of steps, or the activities that you're going to do to implement that business logic. In this case, the factorial calculation, right? So we need to have an algorithm in place first. It is very efficient and of utmost importance that you need to have an algorithm in hand before actually starting off with the implementation, right? That's because it's going to give you a very good idea. And sometimes, the problems are not that simple. It could be a complex problem, and you need to divide that problem to different steps. And that way it becomes easier for other people also to work on their separate entities, and then you can merge the whole program together and create a full sophisticated bot later, right? So what we can do is let's see what an algorithm for a factorial would be, right? We need to create an algorithm first. So this is a functioning factorial algorithm, which says that first we're going to input a number, which is going to be, let's say, num variable from the user. Then we are going to create another variable called fact. This fact variable is going to store the value of the factorial, right? And we're going to put it as a integer variable with a default value of 1. Why 1? Well, a quick fact for you guys that a number which is multiplied by 1 will be the number itself. That's pretty straightforward. So yeah, that's why we're going to go with the 1, because if it would have, let's say, taken 0, then it would have been 0 anytime we multiply it with any number that we have in hand. That's not what we want. And then we're going to do some sort of check whether the number variable that was entered by the user is greater than 1 or not. If it is greater than 1, if the condition is true, right, then we're going to multiply fact with number whatever was there, right, and whatever was entered by the user. So let's say again the number was 5, and factorial currently has a value of 1, which was the default value. So 1 by 5, 1 multiplied by 5 would be the 5 number, and we're going to save this process value, the multiplication value, into the factorial variable itself, right? So now instead of having the default value as 1, fact will have a value of 5. Then we're going to decrement the value of this number variable which was entered by the user by a value of 1. Now number will have a value of 4. Earlier it was 5, right? And then we're going to continue with the loop. Again, we're going to check whether the number is greater than 1. Yes, it is. Multiply this, the 5 variable which currently is held by the factorial variable, with the number which is 4. The value would be stored in the fact variable which is 20. Again, decrement the value of number variable and continue. Once the number value becomes equal to 1 after about 5 iterations, then is 1 greater than 1? No. 1 is equal to 1. It's not greater than 1. So the condition becomes false. So we're going to print the value of fact variable with a message that says, the value of factorial is. And we're going to exit the program. After this message, the value would be there, right, for the factorial variable. And we're going to exit the program. Fairly straightforward, right? I'm going to talk a little bit more about the efficiency and some more use cases or test cases to test, but again, that's a later thing, but we're going to discuss it in this demo itself. Okay, let's start with our program. We keep this algorithm handy, so what we're going to do is we're going to put it something like this, right, just to make your screen more reusable and divide it accordingly. Alright, so we're going to input a number variable from the user, right? If you remember, we just talked about this activity called input dialog. And always give a good number or good message to the activity or good title to the activity so that it becomes easy to understand what this activity is going to do. So we're going to enter the number, right? And what is going to be the title of the window that it's going to show? Always put messages in double quotes and number for factorial calculation. And what's going to be the label? So label is like, the message that you have within the window. Please enter the number, right? And right now, if you'll see, we have nothing in the variables. This was an old thing again. It gets created whenever we create a flowchart automatically in the program itself. And we're going to create a variable, right? Let's create a variable called num, because that's what the algorithm is, right, saying. It's going to be of integer 32. Scope is within the whole factorial calculation itself. And there is no default value needed because we are going to enter some value in this from the user, like, the user is going to enter some value. So okay, the value is entered and we haven't saved this value in the num, right, in this num variable. So I'm going to check the properties for enter num, and you can see there it is. So now the result of this activity would be stored in num, which is going to be the number that user is going to enter, right? Now next step is we're going to create another variable called fact, right? Let's create this variable fact, again of integer type, and it has a default value of 1. That makes sense, right? I hope you guys are keeping up. It's fairly straightforward, right? Now let's create a decision box. I'll tell you why we are doing this, because we're gonna do some looping here. So you want to see whether this number is greater than 1 or not. That's what is being set in the algorithm, right? So in the properties, in the condition, just put number greater number greater than 1, right? That's the condition. You can always do click these 3 dots and you can get the expression editor here. That way it becomes more easier to write down, but I mean either ways, right? It has true and false nodes, which we have discussed in the last blog post itself. So if the number is greater than 1, what are you going to do? This is the true condition, right? Multiply factorial with the number itself. So what we're going to do is we're going to combine these 2 steps together. Multiply fact with number and save this value in the factorial variable itself. So use the assign activity where you're gonna say factorial is gonna have value of factorial multiplied by number. Does that make sense? Calculating factorial, right? That's what it's doing every time. So this is the true condition. So that's how the program is right now. You're calculating the factorial, and you're gonna the next step is that you're gonna decrement the value of number variable by 1. So again, we can use the assign activity. Oops, my mouse. Okay, so you can name this as decrementing number from user, and what you're gonna do is you're gonna take the number and subtract the number by 1, right? And you're gonna go with the loop. So where you're gonna go with the loop, you're gonna check whether the number still is holding, the value of true or not in the decision. Let's name this variable, this decision as well, number greater than 1, something like that, just to make it comprehensible. Okay, and what you're gonna do is, let's connect these as well, and say that, actually, let me make this even better. I mean, just give more space in here so that it becomes, comprehensible again. You have to make your program as easy to understand as possible, always, always. So that's why I have named each and every activity, right? You have decremented the value, and now you're gonna go back to the condition itself. So you're gonna connect this node. Sorry, you don't have to go out of the program again and again. Right, it's automatically gonna do, and hey, come on, there it is. So you have decremented the value which user had provided by 1, and then you are again checking whether the number still holds greater than, a value of 1 or not. If that's how the loop is going to go, and every time it goes, factorial is going to be calculated. Now let's say if it becomes 1, right, the false condition, you want to print the value of the factorial variable with this message, and let's go there. Sorry. Print value of factorial, right? We're going to connect it to the false stage of this program, and the value, this is the message that we had to print, right? The value of factorial is, right? And I'll show you one more thing, right? Once you have to concatenate two different things in a message, in a text, we use a plus sign. So we are printing the value of factorial variable and the message as well in one single line. See, you've gone out, you have checked it here, and you got this blue warning sort of thing, right? That means one or more children have validation errors, which is in here. So there's something wrong with the printing of the value of the factorial variable. What it could be. So imagine that, this message, what, if from strictly from the data type perspective, what exactly a message is gonna be of type? It's gonna be of string type, right? Because, sorry, there's a spelling mistake here, factorial. But I mean, doesn't matter much. Yeah, so this is of string type, right? And we are concatenating that message with an integer value, right? And which is just for the printing purposes. That's what we're gonna do. So for printing purposes, just for this particular activity, what we're gonna do is we're gonna cast, or we're gonna convert this integer into a string. I mean, the variable has not been changed yet, just the value inside it. For printing purposes, we're going to change it to a string. So we are very a lot of inbuilt functions that we have, and to use those functions we use a dot operator. So once you click on once you enter dot, you automatically get some or other functions that you have. So for fact, which is the factorial, right, for 5, which was 120 the value, you want to change it to string to print it. You did that, you clicked outside the activity, and that blue sign is gone. That means it's all good, at least in terms of validation. There might be conceptual errors as well, which again we might encounter in our other programs, but this is a working program right now. All right, so we have the value of the factorial in here, and we are exiting the program, means which is not connected to any other activity. This seems to be a good program, right? Now let's save this first, and let's try to run this. Please enter the number. I'm gonna enter 5 again and see, and the value of factorial is 120. Pretty fast, right? Let's try something else. Let's try probably 12 or something, right? I'm gonna run the program again. 12 is gonna be a little big, but it's all right. 12. The value is this pretty big number. Okay, so the program works fine, right? Now, let's say if I had entered a negative number, right? What would have happened? I don't know, because the program might go in an abrupt loop, might abrupt endly, or might go in an indefinite loop. We haven't tackled that situation yet, right? In the program, we haven't talked about the negative numbers. Let's say if I had entered -5. We don't want to do that because we want to make our program as robust as possible, right? So, to tackle those situations, what should we do? The first and foremost thing is, in the algorithm itself, we need to make a few changes, right? How? Imagine this. We have this entered the number. Yes, I mean that's irrespective, because we need that's going to be the first and the foremost step that we need to have in this program. Create the variable fact. Yeah, okay. Now, or you won't even need to create the factorial variable. What you gotta do is number positive? If true, then follow these steps, all these steps, right? And probably put it something like this. Sorry. That's one of the the beauty of having a. Now, if false, simply print number is negative and exit. Right? I hope that makes sense, because you don't want to create a factorial for a negative number, right? Conceptually, that doesn't exist or something like that. So this is how an algorithm should look like, based on just one change, and based on what you are supposed to do to tackle one more situation of negative numbers, of negative integers. You just made one change at appropriate location in the algorithm, and your solution is somewhat ready, because you have a clear steps, a clear direction to follow, right? So I'm gonna show you how to use this situation now, right? Let's say now we use an if-else box, because we won't be, it's gonna be like all processed sequentially. It's not gonna be like you have to go back and forth again and again, like in a loop in a flowchart. So I'm gonna do an if condition, which I'm gonna put here, right? And check this out. If I can put this as is number positive, right? If the number is positive, which means the condition is gonna be number greater than 0, right? If the number is greater than 0, I want to follow all these steps, correct? I want to go with this, all these things. Now, what I'm gonna do is, I'm gonna take out this arrow by simply selecting and deleting it. I'm gonna actually let it be as is for now. I'm gonna create a flowchart in here, and name it as factorial calculate for positive integers, something like that, right? And in here, in the first step itself, when we had all this this running program, I'm gonna select all these stages. I can simply do Control X to cut these, and in this activity I'm gonna paste it, and I'm gonna connect it with the start activity as well, right? Why? Because that gives all the positive integers would be calculated through this activity. Now if the number is negative, what does the algorithm say, or what was the way for you to handle that test scenario, that use case, right? You're simply saying that you want to print number is negative and you want to exit. So you're gonna, let's say, instead of using a message box, because you have used a message box in when you got the factorial in hand, you're gonna use a write line, which again we talked about in our previous blog post. So if you haven't, please do check that out. In the write line, you simply write the text that says number is negative. That's it. And by exit you mean it's not connected anywhere. So negative integer handling or something, right? So that's how you have handled a negative number. And you gotta connect this program. Sorry. All right, there it is. And you're all set, right? You have a number greater than 0, then you're gonna follow these steps. If not, then number negative, then you got it. So that way you made your program more robust instead of abrupt ending. These are this is again one of the best practices that we should follow, because there might be tremendous amount of test cases, but that's how you have to handle change to the algorithm and put the necessary steps involved in the program itself. Let's run this. Before running, always save your program, and let's run this. Let's close this. Please enter the number. I'm entering a positive number again, let's say 6. Okay, and the value is 720, right? Works fine. Let's try with a negative number this time. We're running the program. We are saying -6 this time, and nothing happened. Why? Guess what? Because negative we are handling by saying the number is negative, but it's a right line, of course. So in the output console, you see number is negative. That's printed. All good. It's working perfect, right? Okay. So in this example, we have used the if-else activity. We have used loops within the flowcharts. We have used input dialog box, message box, write line activity, and that is pretty much it, right? That hopefully gives a pretty good overview of how things are supposed to be in a program. You have to implement the logic based on different activities that you may have, and you need to have an algorithm in hand to start before starting off with the implementation of a bot program. And I also mentioned that in an actual project in a corporate world, you need to have a sign off on the algorithm from your project manager, or in some cases from your client itself, or your point of contact from the client side, to make sure that everybody understands the logic that we're going to implement, and there won't be any confusion. And if there is some sort of discrepancy in the work that you're delivering, then you can always hold the program manager or somebody accountable that this is what was supposed to be done and this is what the bot is doing. Okay, that is pretty much it for this week. Next week we are gonna delve more into loops, because loops is one very, very important and crucial concept. It is, I would say, one of the most fundamental blocks of the whole RPA practice in general. And and we'll see. We'll probably create another demo, something more unusual than these ones. All right. Thank you very much. Hope you guys enjoyed the video. Please don't forget to subscribe, like, share my YouTube channel and my blog post as well. and happy automating. Thanks. Bye bye.